Sathyabama Institute of Science and Technology.
Hello everyone, I am Dr. Cruz Antony, Associate Professor from the Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology, Chennai. Today's topic is about decoding natural language processing. In my previous part 1 video, I explained about what is natural language processing and how natural language processing makes communication between human and a machine and make a machine to understand and process human language. So it also, we have seen in the last video that how NLP uses machine learning and deep learning algorithms to process the unstructured data, analyze it, and then extract relevant information. We also seen NLP systems, various applications like sentiment analysis, machine translations, speech recognition, and text summarization. Today's lecture is about what are the various steps involved in natural language processing pipeline and understanding what is vector and vectorization. So we also see how to perform vectorization technique with the help of TF-IDF vectorization technique. So TF-IDF is one of the popular vectorization technique used in NLP. So we go straight into the steps involved in natural language processing pipeline, especially data pre-processing. So there are various natural language processing pipeline, but we here focus on data pre-processing pipeline. So here we can see the first step is tokenization. So tokenization is the elementary step of NLP, any NLP application. So followed by lowercasing, so changing the case to lowercase, and then stopwords removal we will be seeing in the upcoming lecture, and then punctuation removal, and then finally stemming and lemmatization. So straight away we start with the first step, which is tokenization. So tokenization is nothing but given the input text. So here our input is nothing but the text data, right? So we given the input text, the text gets splitted into individual words, otherwise called as tokens. So here you can see we love NLP with an exclamatory mark. So V becomes one token, love, and then NLP, and finally even exclamatory becomes a individual token. So this is called as tokenization. So the next step is lowercasing. So lowercasing is nothing but changing the case, whatever case might be the input data, it will be changed to lowercase. So here you can see this example, natural language processing, natural language processing. If you see this here in language, for the first sentence, the L is capital letter, and in the second sentence, the L is small, whereas in the third sentence, all letters are capital in the language. For us, we know that all three letters, all three words are same, but for a machine, since case, it is case sensitive, it is considered three different tokens. So hence it is better to change every input data tokens into lowercase. So this is the second step. The next one is stopword removal. Basically in natural language processing we have a concept called stopwords. So in any ML or DL model we have this concept called noise removal, right? So here in natural language processing there are some certain stop words in any language, human language. So such words has to be eliminated. So it is considered as a noise in the natural language processing. So words like is, was, it, it's, he, she, it, they. So these are some of the, you can see some of the stop words in English. So this word has to be eliminated. This doesn't contribute anything towards the accuracy of the model. So hence these words has to be removed. So in our input statement you can see this is a NLP workshop. So after performing stopword removal, the token is and a is removed, only this NLP and workshop has been taken. So the next step is punctuation removal. As I said previously, like we have to remove stop words as it is not contributing towards the accuracy of the model. Hence same way punctuations also has to be removed. So punctuations like apostrophe symbol, comma, and a hyphen between CSE and department has to be removed. So that is the next step. The final one is stemming and lemmatization. So this is not a compulsory step. So in some application stemming and lemmatization is used, not in all applications. So basically stemming and lemmatization both have same objective. The only objective of both stemming and lemmatization is change, given the word, it has to find the root word or the base word. So for example, if you give input word as changing or changed or changer, the base word should be change, right? So that is the objective of both the technique. But the only difference is stemming blindly, it uses the cuts short the prefix or suffix and then it gives the base word, whereas lemmatization, it checks the proper corpus called as the word net. So basically it is like a dictionary, like how for a language we, if we want to refer through, understand a word, we refer a dictionary. Same way this NLP process also refers dictionaries called as corpuses. So one such dictionary is called as word net. So lemmatization refers to give the base word. So that is why you may not see the accuracy level of lemmatization is more compared to stemming. So in stemming you get to have sometimes error in output. So but in other way, stemming is faster compared to lemmatization because stemming doesn't refer any corpus or dictionary, so it takes lesser time to process to give you the base word. So each method has its own advantage and disadvantage. So vectorization. So we have gone through the various steps in pipeline. Now we will see what is vectorization. So vectorization is nothing but we need to convert the text data into numbers. So that is called as vectorization in NLP. So basically you can see there are different types of form. So if you can see this one of the most popular form is tensor. So basically image when it gets converted into in numbers, this is how it looks. So otherwise called as tensors, right? So here our vectorization is this one. So row matrix, otherwise called as vector. So our input data gets converted into this kind of row vectors, otherwise called as vectors. So this is how it looks when text data gets converted into numbers, so that machine learning or deep learning model can understand these numbers and it can do whatever a prediction or classification, whatever task it is intended to do, it will perform. Otherwise it is difficult for a machine to understand our human language, right? So we need to convert into numbers. So this is how it looks. So here you can see in the column the green one, it is nothing but the documents. So the input query. So for example, you imagine you are asking some question to ChatGPT. So the input query is after going through all the NLP pipeline. So this is what the words, okay, the tokens. So it is being listed in the column, and then the query has to be answered, right? So it has to refer to some of the documents over the internet. So those are the documents are stocked here in the row. So whenever a token matches present in the document, so it gets a value more than 0. So it's like a probability. So you can see here document is present here, first is present here, is present here. So if you see here without seeing the numbers, you just focus on only the row, the documents. You can see here. So the document, the first one and the last one matches, because you can see this is the first document. And in the last document you see this the first document. So word wise, token wise, both are same. Only the question mark is extra, which will be eliminated in the punctuation removal. So hence now you can see towards the numbers, you can see the first one and the last one has the similar values. So hence you can say you can classify that the first one and the last document matches. But there are certain tokens which confuses machine learning, like tokens like is, the, this. These tokens have almost same values for all 4 documents. So which confuses machine to classify that all 4 documents are same. So we have to normalize these things. So that is why we have lot of techniques in NLP. One such technique we will be seeing in this video is called as TF-IDF vectorization. So consider this as an example. So I have taken some 4 articles from the internet. So 2 articles belongs to Tesla. So their their news, recent news, and 2 articles is about Apple corporation. So we'll see this is how the data looks basically in the initial phase. So consider this column, as I said earlier, is a input query. So we need to find which are the words is present in the article. So here I have not mentioned which article is what. I have just mentioned article 1, article 2, article 3 or article 4. We will not know which 2 articles are correct, which 2 articles are not. right? So, but with the human eyes, if you see here, so since I have already given you an example that in the previous slide I have told you that we are talking about 2 articles from Apple and 2 articles from Tesla, automatically our human brain thinks about Musk, iPhone, iTunes, Gigafactory, right? So if if there is if a Musk is present in this article 3 and 4, and also you can see Gigafactory, it belongs to Elon Musk, right? So it has a 2 words are present in article 4. So hence we can conclude that article 3 and 4 are same. Same way, you can see iPhone and iTunes have come in both article 1 and 2, and you can say that article 1 and 2 are same category. But so you can see that is what it is, right? But there are certain tokens which confuses machine, like for example that, price, market, investor. So these tokens confuses machine, especially if you see that it has come 32 times in article 1 and 31 times in article 3. Price has come 45 times and 44 times in article 3. So by this token alone, you can also say, machine can also say that, classify that article 1 and 3 are same. Okay, so but that is actually wrong, right? So it has to be normalized. So tokens like price, market, investor has to be normalized, and tokens like iPhone, iTunes, Gigafactory, Musk should increase. So how do we do that? So that is when TF-IDF vectorization comes into handy. So first we need to find the document frequency. So we go from the back side. So first we find out inverse document frequency, then term frequency, and then we multiply it to normalize the data. So first what is we'll see what is document frequency. In document frequency you can see number of times T is present in all docs. So for example, you see for that, for the token that, it has come in 3 articles out of 4. So that is why that value is 3. Price has come 3. iPhone 2 times has come, in 2 articles it has come. Gigafactories has come in only 1 article, so hence the value is 1. So now how do we find the inverse document frequency? So the equation for inverse document frequency is logarithm of total documents divided by number of documents term T is present. So now what is the total document here? 4 is the total document. So now what do you do? So for the value that, for the token that, so it is total document is 4, then it is divided by the value of that 3. So 4 divided by 3 is 1.33, and for Gigafactory it is only 1, actually the value 1 before finding the inverse document frequency. But now when you divide it with the total document, it becomes 4. So you can see here, evidently you can see here, the data is normalized. So Gigafactory's value has increased, that's column like that has decreased. Okay, but now this is a small data set, this is not enough. So in real time, there will be huge amount of data where the query will be referred to. So in that case, it is also important to find the term frequency. How many times that particular word has present in that article, that is must, we need to find out. So that formula is total number of time term T is present in document X divided by total number of tokens present in document X. For consider, for example, for the value of, in order to find the token for that token, so the value is 32. So imagine in article 1 if there are some 100 words present in that article. So the term frequency for the token that is 32 divided by 100. So this is how we find term frequency. So and then after finding that, we multiply it with the inverse document frequency. So term frequency multiplied by inverse document frequency. So you get some data something like this. Okay, so here now you can see. Okay, so the value like Musk, the value has increased 0.99 and 0.95, and you can see the value of Gigafactory, everything has been changed. Okay, so now you can give that data into machine learning for further prediction. So this is the this is why NLP becomes very useful in normalizing, pre-processing the given data. Now we will see about natural language toolkit. So this is, so how do you, so we have seen all the steps. How do you perform these steps in real time with especially Python? So that is where we use natural language toolkit. So this NLTK toolkit, you have to download it and then you can use that library inside, import that library inside the Python programming language, and then you can start performing all this tokenization, stemming, tagging, parsing, semantic reasoning. These are the other tasks under NLP. Okay, so it has actually over 50 corpora. So consider corpora as a dictionary. Okay, so such as wordnet. Wordnet is one such popular dictionary used in NLP. So under NLTK library. So there are also other libraries like Spacey, etc., etc. So which can be used, to perform this NLP tasks. Hope you have enjoyed this lecture. Thank you.